Hello everyone, I'm Amir Hossein. Welcome to this training video. In this video we see how to calculate a satellite's overpassing times in a specific day and over a specific geographical region or country. Like this image that you can see here, you can see Iran's border filled with its flag, and besides with several different satellite footprints. Each footprint is specified with a specific time, and you can easily distinguish that two footprints can cover Iran's region. Two footprints with the times 9:18 and 9:18 UTC and 9:24 UTC. So these two times would be our desired times that we want to calculate in this video. The tool which we are going to use is part of a repository that I have already provided the link of this repository in the video description. So let's just start. I copy the SSH link and I go to the terminal, git clone. I clone the repository. The repository's name is Atmospheric Science. Inside the repository there is a directory called Satellite Overpassing Calculator. I go to the Satellite Overpassing Calculator. This is a program which several different parts or components. The first component is calculator, is a Python code which is the main calculator. Besides two other YAML file, the first YAML is the input data and the other YAML file is the names of the satellite with their indexes. Let me open the input YAML file, and in this input file you see different sections. The first section is about the time range which you want to look up the footprints, the times of the footprints of your satellite. You need to specify a start date and time and end date and time. The second section is the geographical domain which you want to look up the footprints, and you need to specify north and south of the latitudes and west and east longitudes. And the third section is about the satellite name index and data time interval. I will discuss about the data time interval, but first about the satellite name index. There is another file here, satellite names. Let me open it, satellite name, and let me open again the input data. Here the satellite name index of 20 means, I go to the satellite names file, 20 means NOAA 20. In other words, every satellite has a specific index. So if you want to look up for the footprints of, let's say, Meteosat 10, you are supposed to input 24 as its index. So there are, as a whole, there are 58 satellites, 58 different satellites that you can look up their footprints. Okay, I go to the input data, and there is also a data time interval parameter. What is this data time interval parameter? For for example, let's say for the NOAA 20 satellite and for the VIIRS sensor, their data are archived in a special website, and if you navigate into that website you can see that the interval between two data files is actually 6 minutes. For example, the first data is 0, the second data is 6, 12, third data is 12, and so on until the first hour, and after that 1, 6, 1, 12. So there you can see that there is 6 minutes interval between each two data files. So here in the input data, you don't need to put here, let's say 1 or 2, because your archive, your data archive is based on 6-minute interval. But you can search for interval, search for satellite position every 1 minute. That's totally okay, you can do that, but it's not necessary, so I just put here 6 to comply with the intervals in the archive, in the data archive. So let me just run this program calculator for this input data. I run it. You can see that it's looking for the best NOAA 20 footprints over the geographical domain that we specified input data, input YAML file. So they just look up these times every 6 minutes, every 6 minutes step, and in these times it could found an overpassing time, and the other time it could find another overpassing time. So as a whole it could find these 2 times, which are the overpassing times of the NOAA 20 satellite over Iran. And here you can see that we have a new file which has been created after running this program. I open it, and here the found times are written here. So by this way you can easily find any satellite's footprint over a specific region. But let me change the input data for something else. For example, let me extend the range, the time range, and I add 1 day here. So I add 1 day to the end day, and I search it again. I run the program again. Now you can see that it could found much more times, overpassing times. It could find much more times, because here we have 2 days. So the program searched for the footprint times in 2 days instead of 1 day. You can change the indexes to look up for other satellites, and you can extend or change the domain, geographical domain, to search for a smaller or bigger geographical domains.